Hello everyone, welcome to my YouTube channel Pharma Researcher. So this is the second video for Telangana Pharmacist Grade-II exam preparation. The exam which is going to be held on the 30th of November 2024. So this is the new series on our YouTube channel Pharma Researcher, in which we are preparing the MCQ questions for Telangana pharmacist based on the syllabus mentioned in the notification. Like there are total 10 units mentioned in the syllabus, so we have started the first unit, and already the first half of the topics of the first unit have been covered in the first video. I will provide the link of the first video. If you haven't watched that video, you can simply go to that video and you can check out the MCQ questions, and you can also get the PDF of that video. So in today's video, we are going to discuss the remaining topics of unit number 1, and almost half of the topics like pharmacopoeia, packaging and unit operation, these are already been covered in the part 1 video, and the remaining topics like prescription, metrology, posology, dosage form and immunological products, these different topics will be covered in this particular video. If you want the PDF of this particular video, you can simply go to the description of the video, and I will be providing the link of the PDF. You can simply click on the link and you can download the PDF. So let's move to the simply the syllabus part. So this is the unit number 1 for Telangana pharmacist. For unit number 1, it is a part 2 video. So the date of examination is 30th of November 2024, and this is the syllabus. So in this syllabus, the first introduction to pharmacopoeia, packaging of pharmaceuticals and unit operation, these three topics have been already covered. So you can watch this video. Then the remaining prescription, metrology and posology, manufacturing and evolution of various dosage forms, study of immunity and immunological products. These different topics will be covered in today's video. So let's start with the first topic, that is the prescription. In prescription, we have different subtopics like the prescription, in which different parts will be covered, handling of prescription will be there, and then the latent terms and incompatibilities in prescription, which is basically physical, chemical and therapeutic. These three main types of incompatibility. Mostly the question will be asked from the part of the prescription and the latent terms used, and sometimes if more than one question will be framed from this topic, then it can be from the incompatibility. So all these topics are equally important, because the questions have been seen in different pharmacist exam from all these topics. So these all three topics are important from this part. So let's start with the first question of this topic. So the question is, which component of the prescription is not always a requirement? So in prescription, there are different parts of the prescription, and some parts are important for writing the prescription. So the question is like, which component of the prescription is not always a requirement? So first is inscription, subscription, superscription, or prescriber's drug enforcement administration number. So in inscription, the drugs names and quantities are there. In subscription, these are the basically the directions to the pharmacist. And in superscription, there is one symbol like RX, which is which means you take or take though. So it is basically prayer to god Jupiter. So these are the three main parts. Apart from this, there is one part signature, which means the directions to the patients. So these four parts are very important, and the questions mostly framed from these four parts. And these three parts from this particular question, we can say like these three parts are very important for the prescription. But prescriber's drug enforcement administration number, it is not always a requirement. So here option D will be the correct answer. Then coming to the next question. So the question is, the most common criteria used to determine the correct pediatric dose of a drug is. So for correct pediatric dose means basically for the child dose of a drug, what is the most common criteria used to determine this particular dose? So weight is the most important or most common criteria which is used to determine the correct pediatric dose of a drug. So here option B is correct. The next question is prescription is a, so what is prescription? So basically definition has been also asked multiple times. So it is simply a written medical order which is written from a registered medical practitioner and given to the pharmacist in order to prescribe the medicine. So here option C will be the correct answer. Next question is following are the parts of prescription except, so I have already discussed with you the parts, like what different parts are there for of prescription. So here you can find like superscription is a part of the prescription in which RX symbol I have told you. Inscription is basically known as the heart of prescription in which the information regarding the drug and their quantities is mentioned. In subscription, this is regarding the directions directions to the pharmacist, direction to pharmacist. And signa is not basically a part, the part which is similar to this is signature, which is the direction to patients. So these are basically the parts. So here signa is not a part of prescription, so here option D is correct. Then next question is RX is used to denote. So RX comes under superscription. So this we have already discussed. So RX is used to denote superscription. Many times the meaning has been asked for RX. So RX means take though. So there are two meanings. Take though, basically in Latin terms, and you take is the meaning. You take. Then coming to the next question. So the question is subscription in a prescription is a part of. So subscription, this already we have discussed. These are the direction to pharmacist for preparing the prescription. So here option A is correct. Next question is signature is the direction given to. So signature part. So these are the directions given to the patients. So these two things you need to remember. Like these are the similar kind of things. Direction to patients and direction to pharmacist. So for patient it is signature and for pharmacist it is subscription. Then coming to next question. So the question is SOS stands for. So SOS stands for when necessary. So these are basically the abbreviations and Latin terms. These are very important. So from these topics the question will be asked. So I have included in the form of MCQs limited abbreviations. So rest we can discuss in detail in text. So here SOS stands for when necessary. The next question is Orestil is the Latin term for. So Orestil is the Latin term for eardrops. So here option B is correct. So these are very direct questions. There is no need to have the explanation. You only need to remember these things, like what is the meaning. And okay, so next question is meaning of RX is. So RX, again we are revising. RX is superscription, which means you take. So here option B is correct. Next question is primo main meaning. So primo main is a Latin term which means early in the morning. So here option B is correct. Then next question is alternis horis means. So alternis horis, this means every 2 hours. Alternis horis means every 2 hours. So here option C is correct. Then next question is cochlear magnum means. So cochlear magnum meaning 1 tablespoonful. So here option B is correct. Then the next question is meaning of BD is. So BD abbreviation is used for twice a day. So here option A is correct. Then next question is meaning of post sibos means. So post sibos or post sebum. So these means post means after and sibos means meal or food. So here the meaning of post sibos means after meal. So option B is correct. The next question is RX symbol represent dash god. So the symbol RX, which is the part of superscription, which means you take, and it represents the god Jupiter. So here option B is correct. The next question is inscription includes. So inscription is the heart of prescription and it includes the base, adjuvant and vehicle. So these type of the additives which are used to prepare the dosage form and their quantities, these are given in the inscription. So here option D, all of the above is correct. The next question is handling of prescription includes. So handling of prescription, this includes the receiving, reading and checking of prescription, collecting and weighing material, then compounding, labeling and packaging. So these all are comes under handling of prescription. So here option D, all of the above is correct. Then next question is, what does the J on the prescription mean? What is the meaning of J in the prescription? So J means under 16 years age. So here option B is correct. The next question is, the advice on the prescription hora somni means. So what is the meaning of hora somni? So hora somni means at wed time. So here option C is correct. The next question is, QS in the prescription means. So the abbreviation QS, it means sufficient quantity or quantity sufficient. So here option B is correct. Next question is, the term BD in the prescription means. So BD, this we have already discussed. This means twice daily. So here option A is correct. The next question is, the Latin term for mouthwash is. So the Latin term for mouthwash is colutorium. So here option D is correct. The next question is, C opus sit means. So C opus sit, the abbreviation for this is SOS, and the meaning of SOS, C opus sit means whenever necessary. So here option A is correct. The next question is, Latin term for half is. So the Latin term for half is SS. So here option B is correct. Next question is, occusats are. So what are occusats? So these are the eye preparations. So here option D is correct. The next question is, pulvis means. So the meaning of pulvis is powder. So option D is correct. The next question is, which of the following is not a type of incompatibility? So basically there are three main types of incompatibilities: therapeutic, chemical and physical. What organoleptic is not a type of incompatibility. So here option D is correct. Now we can understand like, oh, what are the three main types of incompatibilities and what comes under these incompatibilities. First we can start with the physical incompatibility. So in physical incompatibility, what happens, like whenever two or more substances are combined. Okay, whenever two or more substances are combined together, there we can see a physical change occurs after the mixing of these products, which will be produced an unacceptable product. Okay, so that these type of incompatibility comes under physical incompatibility. Means mostly you will see a physical change. For example, like you can say insolubility, like when you are mixing two mixing two mixing a solid in a liquid, and it will not solubilize. So then that will comes under physical incompatibility. And what we can do for correcting the insolubility incompatibility, so then we need to add a suspending agent. So in that way we can solubilize the compound. Then there is immiscibility. You can find the immiscibility. Insolubility is basically a substance or solid is mixed in a liquid, but immiscibility means mixing of two liquids. For example, oil in water. For example, oil in water or chloroform in water. So based on density differences, these will not mix up. So by adding a suitable emulsifying agent, we can overcome this kind of immiscibility incompatibility. Then there will be precipitation. So this also comes under physical incompatibility. So precipitation, what does that mean? So basically, for example, if I can say like resins are insoluble in water, and they can form precipitates which is indiffusible. So what we can do is we can simply add a suspending agent, for example tragant, which helps to suspend the precipitations. So these are basically the precipitation. So mostly the how the question will come, you can see the questions in the later section. So basically they can ask like precipitation is a type of which type of incompatibility. So you can simply mention like precipitation is a physical incompatibility. Then there is another incompatibility, that is liquefaction. Liquefaction, this is also a physical incompatibility. In this, what happens, like when two solids are mixed. So in liquefaction, what happens when two solids are mixed? So after mixing, they will liquefy each other, and they can form, after mixing, they can form a liquid product. So that is the liquefaction. So basically, to overcome this method, we can use several powders like light kaolin. Light kaolin we can use, or magnesium carbonate we can use, which can absorb the moisture and maintain the free flowing property of the solid preparation. So these are the basic things. So what we have studied in physical incompatibility, you need to remember the four different types, like the insolubility, immiscibility, insolubility for solid and liquid mixing, immiscibility for liquid and liquid mixing, then precipitation, and then liquefaction. So these four you need to remember, like these comes under physical incompatibility method. Then we can come to the second type of incompatibility, that is chemical incompatibility. So what does chemical incompatibility means? So this means whenever there is a chemical interaction between the ingredients of prescription, like there is a prescription, there are different ingredients for the for making the dosage form. So there can be a chemical interaction between the ingredients that can produce a harmful or dangerous product. So basically these type of incompatibilities are of two types. One is tolerated incompatibility, which means the chemical interaction that can be we can minimize this type of interaction by changing the order of mixing. Okay, so this question can be asked like what type of incompatibility can be minimized by changing the order of mixing? Then that will be tolerated incompatibility. Then the another one is adjusted incompatibility. So in this type of incompatibility, we can improve this type of incompatibility by the addition or substitution of the ingredient. Like there are three ingredients, the second one is causing the incompatibility, so we can replace this ingredient by some other substitutable ingredient, so that that kind of incompatibility will not arise. So these are the two main types of chemical incompatibilities. Then after chemical incompatibility, there is therapeutic incompatibility. So therapeutic incompatibility, these type of incompatibilities we have studied in many different areas. Like in pharmacology, we have studied, for example, you must have seen the term synergism, antagonism, antagonism, then contraindication. So these type of incompatibilities are the therapeutic type of incompatibility. You must have seen what is synergism. When two or more substances are combined or given in combination, the effect will be increased as compared to their individual effects. So that is a synergism. What is antagonism? Antagonism means one substance will give the opposite action to that of the drug, so it will produce the opposite effect. So that is antagonism. Then contraindication is like certain drugs should not be used in a particular condition because they can worsen the situation. So these type comes under contraindication. So these are the basic three types of incompatibility. You can also find the PMCQs in the next part from these three main types of incompatibilities. So now we can move to the next question. You can easily find the answers. So the question is, which incompatibility may be corrected by changing the order of mixing? So by changing the order of mixing, which type of incompatibility is there? So this we have seen the tolerated incompatibility, which is a type of chemical incompatibility. Then coming to next question. So question is, crystallization is an example of which incompatibility? So crystallization is a type of which incompatibility? So crystallization is a delayed incompatibility. Basically this type of when crystals are formed, like when we place a solution for some time, then the crystal starts appearing. If it does not appear, we can find a third substance through which the crystals will start forming. So it is not immediately formed, crystals are not immediately forms, but they will form at a later stage. So these are the type of delayed incompatibility. The next question is, there are dash types of incompatibility. So we have seen the three different types of incompatibility: physical, chemical, and therapeutic incompatibilities. Then next question is, liquefaction is a type of incompatibility. So this we have seen in physical incompatibility. So option A is correct. The next question is, precipitation is a type of. So precipitation, again, it is a type of physical incompatibility. So option A is correct. The next question is, alkaloidal incompatibility is a type of. So alkaloidal incompatibility, it is a type of chemical incompatibility. So here option B is correct. Next question is, error in doses is a type of. So error in doses, it is a type of therapeutic incompatibility. So here option C is correct. The next question is, which of the following is a therapeutic incompatibility? So we need to find which is a therapeutic incompatibility. So drug interaction is basically therapeutic incompatibility. So here option A is correct. Alkaloidal salts, these comes under the chemical incompatibility. Precipitation is a physical incompatibility, so that you can remember. Then next question is, which of the following is a physical incompatibility? So basically a type of physical incompatibility is precipitation. So similar type of options are there. So this one is the therapeutic incompatibility, alkaloidal are the chemical incompatibility. So precipitation is physical incompatibility. So with this question, we are completing this particular section, which is the prescription, Latin terms, and incompatibilities. Few more topics we can discuss here regarding the Latin terms. So here I will be providing you the Latin terms. You can write in a copy with you. So I will be discussing few important Latin terms. So let's start with the few those we have already discussed. I will not be discussing here. So rest I will be discussing, like omni mane. Omni mane. So omni mane means every morning. Every morning. Then omni nocte. Omni nocte. Omni means every, and mane means morning. Nocte means night. Okay, so it means every night. Then nocte, simply nocte. So nocte means night. So these and this you can remember. Then there is a Latin term gentaculum. Gentaculum. So gentaculum is basically for breakfast. Gentaculum is for breakfast. Then there is omnihora. Omnihora. Hora means hour. Omni means every. So omni meaning we have already discussed in omni mane. Hora means hour. So omni means every. Hora means hour. Then there is Sibos terms like antecibos, antecibos, post sibos, and intersibos and intersibos. Simply very simple, sibos means meal or food. Ante means before. Ante means before meal. Post means after meal. This question we have already discussed for post sibos. And intersibos means between meals. Between meals. Then there is a Latin term known as lente. So lente means slowly. Lente means slowly. Then there is a term more edicto. More edicto. So more edicto means as directed. So these are all Latin terms you need to remember. The question can be asked from anywhere. Then there is the term statim. Statin. Statin means immediately. Statin means immediately. Then there is semi. Semi means one half. So these are the main Latin terms. So there can be another question for the conversion, like the basically the ML based question. So that we can discuss like conversions for domestic measures. For in this you can write down like drop, one drop. So one drop is 0.06 ml. Basically the values can be changed like 0.06, 0.05 based on the books. Then one drop, then there is one teaspoonful. Teaspoonful. So one teaspoonful is 4 ml. Then one dessert spoonful, it is equal to 8 ml. Then one tablespoonful tablespoonful so one tablespoonful is 15 ml. Then there is wine glassful one wine glassful, so this is equal to 60 ml, 60 ml. Then one teacup full, so one teacup full is 120 ml. And there is tumbler full one tumbler full, this is equal to 240 ml. So these are some basic household measures or domestic measures in which the metric system you must need to know. So these are the metric system quantities. So sometimes the question can be asked from here. Mostly the question you can see from the part of prescription or either from the Latin terms. And sometimes the question can be asked from incompatibility. So all you need to remember. So the first topic is covered. So now we can move to our next topic, which is the metrology and posology, in which we will be covering the calculation of doses on the basis of age, sex, and surface area, percentage calculations, proof spirit, allegation method, isotonic solutions, and displacement values. So many a time the question has been seen from the allegation method or based on the child dose calculation based on age. So this you can remember like the question mostly asked from this particular part. What all the topics are mentioned, so I have included the questions from all these topics, so you have a better idea like from which topic you need to study. So now we can move to the questions. So mostly from the calculation of child doses, I have only included few of the questions to have a understanding like what kind of questions has been asked. Rest I have provided the formulas for you, formulas for each and every category, so that you can simply remember the formulas, and in whatever concept the question has been asked, you will be able to answer that question. Okay, so now we can start the first question from this topic. So the question is, the word posos means. So what is the meaning of word posos? So there is a term posology. It is derived from two words. One is posos and the other is logi. Posos means how much, basically how much, talking about the quantity. Logi means science. Science means how to make the formulation. So it is posos means how much. So here you can the correct answer will be option number B. Next question is, posology deals with. So posology, this term deals with the dose of a drug. So here option B is correct. Next question is, Young's formula is used for calculating the doses for children. So for child dose calculation, there is one Young's formula. The question mostly asked from this particular formula. So Young's formula is used to calculate child doses for children under the age of 12 years. So option D is correct. Next question is, Clark's formula is for calculation of the doses of a drug for children is based on. So there is one formula, Clark's formula, which is used for the calculation of child doses, and it is based on what parameter? So like we have seen in the previous question, like Young's formula is based on the years, like under 12 years we can find out the child dose. So for Clark's formula we can use a body weight. So here option C is correct. Next question is, a pharmacist has 70% solution and 15% solution available with him. He is required to make 480 ml of 30% solution. How he can make? So this type of questions will be solved with alligation methods. Okay, so for alligation method I'll simply write over this particular thing. So I'll simply have a space. So here we can simply find out, we can make roughly 3 columns. First one is percentage given, second one is percentage required, and the third one is parts of individuals, parts of individual quantities. So here percentage given is, so we need to check the question also. So here first I will be writing the percentage given, here in the center I will be writing the percentage required, in the third column I will be writing the parts of individual. So what is the percentage given? So we can see in the question 70% of solution and 15% of solution. So these two values are given. So I will be writing it in 2 columns. One is 70%, other one is 15%. Then in second column we will be writing the percentage required. So what percentage we require? So he is required to make 480 ml of 30% solution. What is the percentage required? Percentage required is 30%. Then the third is parts of individual. So these parts of individual we need to calculate. So in order to calculate we will be subtracting the percentage given from the percentage required in a crossing way. Like from 70 minus 30 it will be 40 parts. So these 40 parts will be of 15%. Then this 15 minus 30, so this we need to put the value in positive only. So it will be 15 parts. 15 parts of what? 15 parts of 70%. Okay, so if you will write these things, so the rest part will be very easy. Now you can see like you have total parts of 15 plus 40, that is equal to total 55 parts. How many? 55 parts. Now you can simply find out the quantities like like we need to find the 15 parts out of 55. Total quantity is 480 ml and these 15 parts will be of 70%. Okay, so if you have remembered this thing, so I will be erasing this part and I will be writing here like there will be 15 parts of 70% and there is 40 parts, 40 parts of 15% solution. These two quantities we will be having. So now how much volume we need to make? We need to make a total of 480 ml. We have total parts 15 plus 40, 55 parts. Now we will be calculating for the first, out of 70% how much we need to take. So there are total 15 parts out of 55. Like we, if we add this will be 55 parts. How much quantity we will need to make? We will need to make 480 ml. So while solving this particular thing, we will be simply getting the final answer 131 ml. Okay, because it is 480 ml. So out of 480 ml, 131 ml we need to add from what? From 70% solution, because these 15 parts are from 70% solution. So we have 70% solution. We will be adding 130 ml. We will take 131 ml of 70% solution and the rest we will take from the 15% solution. Now we also need to calculate the 15% part. So in the similar way we will make 15 15 out of 55 multiply by 480 ml. Now after solving this particular equation we will be getting 349 ml of 15% solution. Okay, so we have both the conditions, like for 70% we will be having uh, 70%, 131 ml of 70%, and 349 ml of 15% solution. So here the answer will be option number C, correct. Also, if there are multiple solutions, okay, so right now in this question there we have only taken two solutions. If we need to make from the three solution or four solution, then how we can do? So the condition will be same, like we will be adding, like here will be A required, B required, and C required. Here it is a percentage given, and percentage required will be here in the center. We will be writing the like D, this is the percentage required, and simply we can simply crossing minusing the values, and we will be getting other things. Like here we will be getting E, F, G parts. So E parts of A percent solution, F parts of B percent solution, G parts of C percent solution, and the division will be like here you will be getting 1, 2, and 3. Okay, you will be getting 1, 2, and 3 parts. So the total will be 6 parts. So one part of 6 part multiply by the total requirement, that is Z. So in that way you can calculate the quantities if more than 2 percentages are given. So this is quite easy. Then we can move to the next question. So the question is, according to IP Indian Pharmacopoeia, an elixir containing 42% volume by volume alcohol, what is the proof spirit? So this is the question regarding the proof spirit. Very simple formula is there for proof spirit. So basically what happens, so there is elixir, we have the quantities of alcohol, that is 42% volume by volume alcohol, and we need to simply find out the proof spirit based on as per the Indian Pharmacopoeia. So as per Indian Pharmacopoeia, the proof spirit is equal to percentage volume by volume multiply by 1.753. So this formula is applicable for Indian Pharmacopoeia as well as British Pharmacopoeia both. So we have the percentage volume by volume given, that is 42% volume by volume. We can simply multiply with 1.753. So what happens? Proof spirit is equal to percentage 42% volume by volume multiply by 1.753. After solving this, we will be getting the value 73.8. So here option C will be the correct answer. Now, if not as per Indian Pharmacopoeia, the question will be asked from as per the United States Pharmacopoeia. Then there is a slight change in the value. Like you can simply write out the percentage strength or percentage volume by volume multiply by 2. The value will be changed to 2. As per Indian Pharmacopoeia and British Pharmacopoeia, value is 1.753. As per United States Pharmacopoeia, it will be 2. So this is the basic difference. So in that way you can find out the proof spirit. The next question is, which formula is used to calculate child dose based on surface area? So based on surface area, we will use Quetzal's formula to calculate the child dose, and the formula which we use we will be discussing in later in this particular video only. Then next question is, the adult dose of a drug is 250 mg. What would be the appropriate dose for a 6-year-old child weighing 60 lb? So here we have adult dose, we have age in years, we have weight in lbs. So we can find out the child dose from age also and from weight also. But here we have specifically mentioned why Young's formula we need to calculate. So why Young's formula? What is child dose? So child dose is equal to age in years divided by age in years plus 12 multiply by adult dose. So this is the formula. So simply what you can do is you can simply add the value. Age is 6 year divided by 6 plus 12 multiply by adult dose is 250. So after solving this equation, you will be getting a value approximately 83.3%, 83.3 mg. So the nearby value is 83. So here option B will be the correct answer. Then we can move to the next question. So the question is, what is the dose for a 6-month-old infant of drug having adult dose of 300 mg? So we have months of child. So for if the age is given in months, then we will use the formula Fried's rule. Fried rule. In Fried rule, child dose is equal to age in months, age in months divided by 150 multiply by adult dose. So here age is 6 months divided by 150 multiply by adult dose is 300. So simply we can cancel it out with 2, then 6 into 2 is 12 mg. So here option D will be the correct answer. Then we can move to the next question. So the question is, what percentage of sodium chloride is said to be isotonic? So the percentage of sodium chloride that is isotonic with the body fluids is 0.9%. So here option A will be the correct answer. Now what is the meaning of term isotonic? Isotonic means they will be having the same osmotic pressure as of the body fluids, means the solution will be having the same osmotic pressure, or isotonic means there is an equilibrium with the concentration of solute inside and outside. So if the value is less than 0.9%, okay, if the value is less than 0.9%, for example if it is 0.2%, 0.5%, then it will be hypotonic. Hypotonic means there will be swelling of the cells. Okay, we can see a swelling conditions in case of hypotonic. And if the value is higher, for example like if it is 1.2% or 3%, then the solution will be known as hypertonic, and the condition seen will be shrinkage. Condition seen will be shrinkage. So there are three conditions. One is hypotonic, second one is isotonic, and the third one is hypertonic. This we can revise once again. So hypotonic means the less than the isotonic value, means solute inside is greater than solute outside. Isotonic means solute inside is equal to outside, and in hypertonic solute inside is less than outside. So these are the three conditions. Now what is the effect if we provide this solution to the body fluids? So basically if hypotonic solution is given, then there will be swelling of cells. Then the phenomena you can say is swelling of cell. If isotonic, then this will be the equilibrium, there will be no effect. What if there is hypertonic solution? Then there you can see the shrinkage. So these three things you need to remember. Okay, so isotonic, you need to remember the value for sodium chloride, and the conditions with hypotonic and hypertonic. Now we can move to the next question. So the question is, calculate the amount of sodium chloride required to make 200 ml of 1% solution of calcium disodium adentate isotonic with blood. So we need to calculate the amount of sodium chloride which we need to require to make 200 ml. Final quantity will be 200 ml of what? Of 1% solution of calcium disodium adetate, which should be isotonic with the blood. And we also having two values like the FP, that is the freezing point of 1% calcium disodium adetate is 0.12 degrees Celsius, and the freezing point of 1% sodium chloride is 0 minus 0.58 degrees Celsius. So here what we can do, we have these two values. Now we will be simply applying the formula percentage of adjusting substance, percentage of adjusting substance. Okay, so here there is a very simple formula for percentage of adjusting substance. You will be simply putting 0.52 minus a whole divided by b. So first we need to minus the term and then we can divide the term with b. Now what is a and b? So here a is the freezing point of drug. A is the freezing point of drug. And what is b? So b is the freezing point depression. It is freezing point depression of adjusting substance, of 1% adjusting substance. So what we can see is, so freezing point a here, that is freezing point of drug, that is calcium disodium acetate. We have the value 0.12 degrees Celsius. And for b, that is the freezing point depression of the adjusting substance. So this is the adjusting substance, that is sodium chloride. So the freezing point is given minus 0.58 degrees Celsius. We can simply put the values. For example, it is 0.52 minus 0.12 whole divided by 0.58. So after solving this will be 0.40 divided by 0.58. So that will become 0.69%. So this is the percentage. So now we need to find out the grams required for the quantity 200 ml. So this is for the 1% solution. So 1%, what is the meaning of 1%? So 1% means 1 gram in 100 ml. Okay, so for 200 ml there will be 2 grams. Okay, so this is 0.69%. So for 200 ml we need to simply multiply this quantity, because we have 200 ml, so we need to multiply it with 2. So we have 0.69 percentage, it will be multiplied with 2, which will become 0.138 grams. So here the correct answer will be option number B. 0.138 is the correct answer. Then we can move to the next question. So the question is, determine the displacement value of medicament in theobroma oil suppositories containing 40% medicament prepared in 1 gram mold. The weight of 10 suppositories is 14.66 gram. So this displacement value is mostly seen in the suppositories calculations. So basically what happens is, there is several displacement due to the addition of the bases. So that displacement value we need to calculate. Now firstly we will be identifying like what conditions or what values we are having. So determine the displacement value of medicament in theobroma oil suppositories containing 40% medicament. Okay, so we have the 40% medicament which is prepared in 1 gram mold. Now the total weight we have given like 10 suppositories is 14.66 grams. So simply we will find the weight of 10 suppositories. So weight of 10 suppositories is 10 suppositories containing theobroma oil alone prepared in 1 gram capacity is 10 grams. Okay, so 1 into 10 simply. So it will be 10 grams for 10 suppositories, and in the 1 gram mode it will be 10 grams. Now the second thing we need to calculate is weight of 10 suppositories containing 40% medicament. Second weight is weight of 10 suppositories, containing 40% medicament, that is given 14.66 grams. Third is amount of theobroma oil present. What is the amount of theobroma oil present? So this is 60 by 100 multiplied by 14.66. Okay, so 16 is the remaining quantity of theobroma oil, and out of 100% we are calculating, and total weight is 14.66. So this will become 8.79 grams. So what is the amount of total theobroma oil present? So theobroma oil, because we have 40% medicament, So the remaining is 60%. So 60% is theobroma oil only. So like that way we have calculated like 8.79 grams will be the amount of theobroma oil present in this. Second, we can calculate the amount of medicament, like what is the amount of medicament present. So in the simple similar way, like 40% is medicament out of 100%, multiply by what is the total quantity is 14.66, that will equal to 5.86 grams. Now the amount of theobroma oil. Now we have to calculate the displacement value. So how the amount of theobroma oil displaced by 5.86 gram of medicament. So it will be total 10 grams are there. 10 grams we have calculated like weight of 10 suppositories containing theobroma oil alone. Like if only there will be theobroma oil, no medicament is there, so then there will be 10 grams because there is a capacity of 1 gram mold. So total theobroma oil will be 10 grams. So now we have 10 minus 8.79. 8.79. What is 8.79? 8.79 is the value uh, that we have calculated for the amount of theobroma oil present, like amount of theobroma oil present, that is from the 60%. So this the final value is 1.20 gram. Okay, so now we need to find the displacement value of medicament. What is the displacement value? Displacement value. So simply we can find out like the amount of medicament is 5.86 grams divided by 1.20. Okay, because 1.20 is the amount of theobroma oil which will be displaced by the 5.86 gram of medicament. So here simply by dividing it, it will come approximately 5, value of 5. So here the correct answer will be option number C. So this is a correct answer. You can simply revisit the values and you can simply find out like how we have calculated the displacement value. Simply we there are 3 or 4 steps. First we need to find out the weight of 10 suppositories with theobroma oil alone. There is no medicament. Okay, so that we can simply find out from the mold, like there is 1 gram of mold and total 10 suppositories, so there will be 10 grams of theobroma oil alone. Then we have weight of 10 suppositories with medicament and with theobroma oil, that is 14.66 grams. Then we will find out the amount of theobroma oil in this value 14.66 gram and the amount of medicament here. Now we need to find, next step is we need to find out the what amount of theobroma oil will be displaced by the amount of medicament. So simply we will be finding the total amount for the theobroma oil alone, then we will be subtracting the total amount of theobroma oil already present. Then simply we will be having the value, then we can simply divide that particular value of theobroma oil displaced with the amount of medicament present, because the theobroma oil will be displaced with the amount of medicament. So like that way we can find out the displacement value. So these are the most important questions, like the basic questions from each topic. Now we can simply move to the calculation of doses, like what different formulas are there and where they have been applicable. So first one is Young's formula. So it is for the children under 12 years of age. Formula is quite simple. The child doses age in years divided by 12 plus age in years multiplied by adult dose. So in that way we can find out this. If they have specified Young's formula, you can calculate the value based on Young's formula. If it is if they have mentioned any other formula, then you can mention in that way. Next formula is Dilling's formula. So it is for the children between 4 and 20 years. So the formula is simple: child dose is equal to age in years divided by 20 multiplied by adult dose. Then next formula is Cowling's formula. So it is for the children's which is having higher age. For like the formula is age in years plus 1 divided by 24 multiplied by adult dose. So this is the formula for Cowling's formula. Then next formula is Fried's formula. This we have already have a discussion on a particular question. So child dose is age in months divided by 150 into adult dose. Then next is Best-Tedor's formula. So Best-Tedor's formula is uh, child dose is equal to age in years plus 3 divided by 30 multiplied by adult dose. So like that way you can calculate the child dose for children's which is having higher age. Then next formula is the calculation of doses based on body weight. If you need to calculate the child dose based on body weight, then you can use the Clark's formula, which is child dose is equal to child weight in kg divided by 70 multiplied by adult dose. So in that way, like we have a question like which formula is used to calculate the child dose based on the body weight. So that is Clark's formula, and like that way if it is given in lb, then you have to convert the weight in kgs and then you can find out the child dose. Next is calculation of doses based on surface area. If surface area is there, then how you can calculate the child doses? So the formula for this is Quetzal's formula. So this question can also be asked like which formula is used to calculate the child doses based on surface area. So it is Quetzal's formula. So the formula is child dose is equal to body surface area of child in meter per square divided by body surface area of adult, that is 1.73 meter square, multiply by adult dose. So this is quite simpler formula. So now we can move to the next formulas, that is the percentage calculations. So basically if you need to calculate the percentages, so volume of stronger alcohol to be used. Okay, so if you need to calculate the volume of stronger alcohol that to be used, so the formula is volume required multiply by percentage required divided by percentage used. So this is quite simple, like all these values has to be given in the question. So in that way you can easily find out the volume of stronger alcohol to be used. If it is stronger acid, if it is for stronger acid, then there is not much change, only the volume required will be replaced by weight required. So like that way you can calculate the percentages. So why these formulas, this topic is also covered. So now we can move to the next part, that is the manufacturing and evaluation of various dosage forms, that is tablets, capsules, suppositories, emulsions, suspensions, lotions, ointments, creams and paste, parenteral and ophthalmic products. So from all these topics we will be having the questions in this particular section. So let's start with the first question from this section. So the question is, from the point of view of dissolution, which of the following dosage form is least absorbed? So based on dissolution, like which of these dosage form is least absorbed? So coated tablets, solution, suspension, or uncoated. So the solutions and suspension, these will be absorbed very rapidly because the drug is already in the solution form, so it does not need to be go in the solution form, already in the solution form, so it will be rapidly absorbed. Then the uncoated tablets, so uncoated tablets then will be absorbed later as compared to solution and suspensions, because the tablet first go in the solution form, break down, and then it will be ready for the absorption. Coated tablets, so coated tablets, first the coating layer will be breakdown, which is not breakdown in the gastric acid. So these will be breaking down in the intestine only, and there they will be absorbed. So coated tablets will be least absorbed as compared to the other formulation. So here option A is correct. The next question is, the rate limiting step for the absorption of liquid soluble drug from the immediate release tablet is the rate of. So for immediate release tablets, what is the rate limiting step for the absorption of liquid soluble drug? So the rate limiting step will be the transport of the drug molecule across the intestinal mucosal tract. So here option D is correct. Then next question is the 000 size capsule can fill the volume of. So there are different sizes of capsules, and the 000 size capsule is the largest capsule size, and it is having the volume of 1.36 ml. So here option C is correct. There can be variation in these values, like somewhere it can be written as 3.5, somewhere it can be written as 3.7, or sometimes it can be written as 1.40 ml. So the closest value that will be given in the paper that you can follow. Apart from this, this is the largest capsule size. If I'll talk about the other capsule sizes, so after 000 there will be 00, then 0, then 1, 2, 3, 4 and 5. So these are the different capsule sizes. 5 is the smallest capsule size, and now we can find out like what approximate volumes in mls that can be filled in the capsule. So for 000 we have seen it is 1.36 ml, and if I'll talk about in mgs, like what is the quantity in mg for 000 capsule, then it will be around 950 mg, 950 or 960 mg approximately. Then if I'll talk about the 00 capsule size, it will be 0.95 ml and 650 mg. Okay, either 0.95 ml or 650 mg. If it is single zero, then it will be 0.75 ml. So consider these values an approximate value, because book to book these values can be little varied. So for single zero capsule size, it is 0.75 ml, and or 450 mg. For one size, it is 0.55 ml and 300 mg. For size number 2, it will be 0.4 ml and 250 mg. For size 3, it will be 0.3 ml and 200 mg. For size number 4, it will be 0.25 ml and 150 mg and 150 mg. And for size 5, which is the smallest size, so it will be 0.15 ml and 100 mg. So these quantities you need to remember, like the question can be asked from these quantities in order to increase the difficulty levels. Then next question is filling of pellets in capsules is done by. So the capsule filling in capsules, the pellets are filled by with the help of rotofill. So here option B is correct. Next question is filling of liquid in capsules is done by. So the filling of liquids in capsule is done by Qualiseal. So option B is correct. Next question is separation of tablet into two or more distinct layers is. So if the tablet is separating horizontally in two or more distinct layers, then this is called a tablet defect, which is known as lamination. So option C is correct. Next question is tablets that are placed under the skin are. So those tablets which are placed under skin are implants. So option C is correct. Next question is rate of dry glycerin to dry gelatin for hard gelatin capsule is. So for hard gelatin capsule, we need to find out the ratios for dry glycerin to dry gelatin. So it will be 0.4:1. So option B is correct. Next question is an unequal distribution of color on the surface of tablet is called. So it is also a tablet effect in which there will be unequal distribution of color on the tablet surface. So this defect is known as mottling. So your option D is correct. Next question is in dissolution experiments, which one of the following coated basket is preferred when the acid medium is used? So in dissolution experiments for coated basket, if coated basket is preferred, then gold gold coated basket is preferred when acidic medium is used. So here option B is correct. The next question is, tablets that after oral administration release the drug at desired time for prolonged effect is called. So those tablets which are given orally and they can release the drug at a desired time for prolonged effect. Okay. So for a long period of time they will be producing their effect. So these type of dosage forms are known as, or these type of tablets are known as sustained action tablets. So here option D is correct. Then next question is, the availability of drug for absorption decreases in the order. So what is the order of availability for absorption? So here we can see like mostly the capsules will be absorbed rapidly as compared to tablets, compressed tablets and enteric-coated. Enteric-coated will be lastly absorbed because there is a coating on the tablet which protect the tablet in the acidic environment of the stomach, producing it to be released or absorbed in the intestine. Then after capsules, the tablets, and then compressed tablets, and then at last enteric-coated tablets. So here the correct order will be option number C. Next question is, which one of the following test is not official in Indian pharmacopoeia? So the non-official test in Indian pharmacopoeia is friability. So here option B is correct. So friability is basically a test which is used to check the durability of the tablets during the transportation or abrasion or shock. So for these conditions, the friability test is done, and this test is basically done in a fibrillator that is known as a Roche fibrillator, and this apparatus utilizes a time of 4 minutes, and it is rotating on a speed of 25 rpm, which gives a total time, which gives a total rotation of 100 rotations or revolutions after 4 minutes. So like that way this fiability test is performed. The next question is, which is not a type of tablet? So here the pessaries are not a type of tablets, these are the type of suppositories. So here option C is correct. And troches, lozenges, effervescent tablets, tablet triturates, these are the different types of tablets. Next question is, type A gelatin exhibits an isoelectric point at pH. So there are two types of mainly gelatins, type A and type B gelatin. The type A gelatin is having isoelectric point at pH 9, and type B gelatin is having isoelectric point at pH 4.7 approx. So here option C will be the correct answer. Next question is, capping is due to which of the following reasons? So what is capping? Capping is a defect of tablet in which the tablet is uh, breaking into two equal parts or two parts horizontally. Like here it is a tablet, and this tablet is breaking horizontally from here and into two parts. So this is the capping, and this defect is due to air entrapment or due to high compression force or due to too rapid expansion. So these are the different reasons due to which capping defect arises. So here option D, all of the above is correct. Next question is, gelatin is used as a, so gelatin it is basically used in capsules as a encapsulating agent. So here option A is correct. Next question is, bloom is a measurement for dash of gelatin molecules. So bloom, so basically bloom strength is there for gelatin molecules, which is used to measure the cohesiveness between the gelatin molecules. So here option D is correct. Next question is, dash is widely used in chewable tablets. So in chewable tablets, the most widely used ingredient is mannitol, which provides the sweet taste. It is a sweet material which is used in the chewable tablets. So option B is correct. Next question is dash is an enteric coating material. So the question is many times asked from the enteric coating materials. So the enteric coating material is cap, which is cellulose acetate phthalate. It is cellulose acetate phthalate. So it is an enteric polymer. So mostly you can find out if there is a term phthalate with the ingredient, then you can easily identify like this is a enteric polymer. Apart from this, there is a compound hypromellose phthalate. It is hypromellose phthalate or polyvinyl acetate phthalate or shellac. Shellac is also enteric material, enteric polymer, or there is polymethacrylates. Polymethacrylates. So these are also the enteric materials. Then coming to the next question. So the question is diclofenac tablet coated with cellulose acetate phthalate has been administered to a patient. Where do you expect to be released? So if any tablet which is coated with enteric material, that is here they have used cellulose acetate phthalate, so that tablet will be released in the small intestine only. So here option C will be the correct answer. Next question is the purpose of seal coating in sugar coating process for tablet is. So in the sugar coating process there are several steps. For example, seal coating, there is sub coating, there is syrup coating or smoothing process, there is polishing. So these different steps are there in sugar coating process, and most important are seal coating, sub coating, syrup coating. From these three steps the question is mostly asked. So basically the question is asked from the purpose only. So the purpose of seal coating in sugar coating is to prevent moisture penetration into the tablet core, that is given in option number A. So here option A will be the correct answer. And here for seal coating, shellac is used or zain is used. So these are the sealants which are used. Then the second step is subcoating. It is also equally important. So subcoating, why subcoating is done? So subcoating is basically done to round the edges and build up the tablet weight. So why this process? The tablet is weight is increased by 50% to 100%. The weight is increased of the tablet. Then the third step, that is syruping or syrup coating. So it is basically done in order to impart the round of the edges or any imperfection that is caused due to subcoating. So that imperfections will be corrected with syrup coating process. So these three purposes you must need to know for these sugar coating processes. Then coming to next question. So the durability of a tablet to combined effect of shock and abrasion is evaluated by. So it is evaluated by the frivolator, in which Roche frivolator is used, that I have already discussed with you. So this you need to know. Next question is a super disintegrant in tablet formulation is. So which one is the super disintegrant in tablet formulation? It is sodium starch glycolate. So here option A is correct. Next question is LAL is an in vitro test and it is used in parental products to detect. So LAL is Limulus amoebocyte lysate test. Limulus amebo Limulus amoebocyte lysate test. So it is an in vitro test and it is used for the evaluation of parental products for the detection of pyrogen. So pyrogen testing uses the LAL test. So option D is correct. Next question is the following are the oily solvents used for parentals except. So which oily solvent is not used in parentals? So cottonseed oil, sesame oil, ethyl oleate, castor oil. So castor oil is the one which is not for used as a solvent for parental. So here option D is correct. Next question is, and the antimicrobial agent used in the ophthalmic solution is. So which antimicrobial agent is used in the ophthalmic solution? So this antimicrobial agent is chlorhexidine. So option A is correct. Next question is, which is correct for water for injection? So we need to find out the correct statement regarding the water for injection. So in water for injection, there should be several limitations, like it should be pyrogen free and the solid content should be 10 parts per million. So here option B will be the correct answer. Next question is, ascorbic acid is a preservative used in parental formulation which act through. So here you need to remember the two important things. Like for the ascorbic acid, what is the use of ascorbic acid in parental formulation? So it is used as a preservative. And how it act as a preservative? So it act as a reducing agent. So here option B is correct. Next question is, which of the following parental container material shows the highest gas permeation? So what type of parental container material showing the highest gas permeation? So this material is polystyrene. So here option B is correct. Next question is, space requirement for manufacturing parental is. So the space requirement for parental manufacturing is 60 meter square. So option B is correct. Next question is, which of the following is commonly used as a preservative in eye drops? In eye drops, that is the ophthalmic product, the preservative used is benzalkonium chloride. So here option D is correct. Next question is, which of the following dye is used for the leak test? For leak test, which dye is used? So the dye which is used for leak testing is methylene blue dye. So here option B is correct. Next question is, in tablets, magnesium stearate is used as. So in tablets, the use of magnesium stearate is as a glidant as well as lubricant. So here option C, both A and B is correct. So what is a glidant? So glidant is a substance that is added to the powder to improve the flowability. Flowability. And what is the role of lubricant? So lubricant are basically those substances which reduces the interparticular friction during the compression, and they reduces the friction between tablet and dipole. Between tablet and dipole, they simply reduce the friction during the ejection of tablet, so there will be no sticking to the dipole or with the punches. So that is the main work of lubricant. So magnesium stearate is used as both glidant and lubricant. Then coming to next question. So the question is, separation of tablet into two or more distinct layers is. So if the tablet is separating into two or more distinct layers, then this one will be the lamination defect. So option B is correct. If I'll talk about capping defect, so capping defect is simply the term capping is used when either the upper or lower part of the tablet separates horizontally, either partially away from the main body or completely to form a cap. So this is the capping defect. Means simply it is breaking into two parts, and the body and the upper and lower body will be separating horizontally. Like this is the tablet, so it will be breaking from here, and this other both the parts are being separated. Then talking about picking. So picking is a type of defect in which the material becomes stuck on the faces of the compression tooling. Or what we can say is, like here we have a tablet. There is a logo and something like that. And when we are punching this thing, so during punching it will the material will stick to the punch or either to the die ball, so that thing will comes under picking. Then coming to sticking defect. So sticking defect is a type of defect in which the material is being stick or adhere to the dye wall, and it is simply fixed on the dye wall, and the tablet will be improperly ejected. Then coming to next question. So question is breaking of tablet edges is known as. So if tablet edges are breaking, then this type of defect is known as chipping defect. So here option B is correct. Mottling we have already discussed, like it is the improper coloring or unequal distribution of coloring. Lamination we have discussed, like it is the separation of tablet into two or more parts horizontally. Sticking means the tablet is stick to the dye wall. So these are the different things. Next question is titanium dioxide is used as. So titanium dioxide, it is used as a opacifier in the tablet coating formulation. So here option A is correct. So you can also write the formula like TiO2 is the formula for titanium dioxide, which is used as opacifier. So why opacifiers are used? So opacifiers are basically are the substances which are added to the material in order to make the ensuing system opaque. If we need to make the system opaque, then we need to add the opacifiers. There are several other ingredients or other formulations of the tablet coating, which includes plasticizers. So plasticizers, there are different examples of plasticizers like poly, or we can say propylene glycol or polyethylene glycol. These are the plasticizers examples. Then if I'll talk about the enteric polymers, so enteric polymers I have already discussed, like cellulose acetate phthalate, hypromellose phthalate, polyvinyl acetate phthalate, shellac, polymethacrylate, that we have discussed in the previous question. Non-enteric polymers are like hypromellose, there is hydroxyethyl cellulose, hydroxypropyl cellulose. So these different types of agents are ingredients are used as non-enteric polymers. Now coming to next question. So the question is Worcester process can be used to. So Worcester process can be used to coat the tablets. It is a tablet coating uh, process. So here option A is correct. So basically there is a method or equipment that is fluidized wet coater. So in that there will be different mechanism for the coating of tablets. So in that the one is the Worcester process, in which there will be a bottom spray process. It is a bottom spray process for the coating of tablets. The second one is granulator. The second one is granulator. It is in the fluidized bed coater only. So it is the granulator which is having the mechanism of top spray top spray system. So this question can be asked like which one is the bottom spray process in fluidized bed coater. So that will be first process. If it is a top spray, then it will be granulator. If it is a tangential spray, okay, if it is a tangential spray, the third one, then it will be the rotor processor. So these three you need to know. Then coming to next question. So the question is coating material fills in the logo on the tablet is a type of which defect? If there is a tablet, there is one logo, and there will be some empty space in this logo. So if the coating material is filled in this empty space, that kind of tablet coating defect is known as bridging. So here option B is correct. There are several other defects also of coating like orange peel effect. This effect will be like you can see like there is a orange peel. So the tablet surface will be appearing like a orange peel. So that will be orange peel effect defect. Then there is a flaking defect. Flaking means in this defect the coating material is removed as a flakes. Like there is a tablet and the coating material will be removed as a layer, you can say as a layer. So the layers will be removed, like you must have seen on the walls of the room, like from the bottom the material or the paint material is removed as a flakes. So that is the flaking defect. Then coming to next question. So the question is, what are the temperature conditions for disintegration test apparatus? So the temperature condition for disintegration test apparatus is 37 plus minus 2 degrees Celsius. So here option A is correct. If the question is asked for dissolution test apparatus, if the question is asked for dissolution test apparatus, then the temperature condition will be 37 plus minus 0.5 degrees Celsius. So that you need to remember. Next question is, test animal used for pyrogen testing is. So for pyrogen testing, the test animal is rabbit. So option C is correct. Next question is, the body of the hard gelatin capsule is dash in length as compared to cap. So for hard gelatin capsule, there will be a body, there will be a cap. Okay, so the body of the hard gelatin capsule will be larger in length and the will be larger in length as compared to cap. This is the cap, this is the body. So the material is filled in the body and a cap is placed over it. So this cap will be small. So basically what happens is the length is higher, but if we'll talk about the diameter, then the diameter of this body will be lesser as compared to the cap. So this is also one of the difference. The next question is, which of the following is not a step in production of empty hard gelatin capsule? So in order to make or in the production of hard gelatin capsule, there are different steps involved. So dipping, spinning, drying, these are the important steps in the production of hard gelatin capsule. Like what cross linking is not one of the steps. So here option D is correct. Now I can tell you like what are the different steps. The first step is dipping. This is the first step. Second step is spinning. Third step is drying. Then the fourth step is stripping. Fourth step is stripping. Then fifth step is trimming or cutting. Then after trimming or cutting, there will be next step, sixth step, that is the joining, and the seventh step will be polishing. So with the name only you will be able to know like what work is going to be done in these different steps. Then coming to the next question. So the question is, for uniformity of weight, how many capsules are taken? So this is the evaluation test for the capsules. So uniformity of weight, in uniformity of weight test, so we will be taking initially 20 capsules, our first weight individually. We will be taking the weight individually. Then we will take the weight of overall, and we can take the mean weight of the individual capsules. Now the weight of each capsule should not vary much within the limits as compared to the average weight. So this we will be checking in the uniformity of weight. If we'll say like in the test of uniformity of content, so in case of uniformity of content, we can take 10 capsules, okay, for evaluation. So this difference you can remember. Like for uniformity of weight, it will be 20 capsules. For uniformity of content, it will be 10 capsules. Then coming to next question. So the question is, moisture content present in hard gelatin capsule is. So the moisture content which is present in hard gelatin capsule is 12 to 16%. So here option C will be the correct answer. If we'll talk about for soft gelatin capsules, the moisture content can be 6 to 10%. So this is the main difference. So then coming to the next question. So the question is, Dash are semi-solid dosage form meant for insertion into body cavity. So these are the semi-solid dosage forms which are inserted in different body cavities, and these are the suppositories. So here option C will be the correct answer. The next question is, which suppositories are meant to be inserted through vagina? So through vagina, the suppositories which are inserted are known as pessaries or vaginal suppositories. Vaginal suppositories. Other different types of suppositories are urethral. Urethral suppositories are also known as bogies, and these are inserted through the urethra. Then there are rectal suppositories. These are inserted into the rectum. Nasal suppositories Nasal suppositories are also known as bogies, and these are inserted through nose. Then there are eye cones. These are inserted through eyes. So these are the different main types of suppositories, and mostly the pessaries will be asked because it is a different name. Another name that is asked is bogies. So urethral bogies are also there, nasal bogies are also there. So you can remember both of these. Then coming to the next question. So which of the following is oleaginous suppository base? We need to find out the oleaginous suppository base. So there are different types of suppository bases are there. First one is oleaginous suppository base. Another one is second one, I can say second one is aqueous base. Aqueous base, which is also known as water soluble or water miscible base. And the third one is the emulsifying base. Third one is emulsifying base. So you need to remember all the examples of bases that are used in suppository. So here we have asked like which of the following is the oleaginous suppository base. So here the theobroma oil is an example of suppository base. Apart from theobroma oil, which is also the cocoa butter, there is hydrogenated oils. These are also used as a oleaginous base, and these oleaginous bases are also known as fatty bases. Then if I'll talk about the another type, that is the aqueous bases or water soluble bases. So in this the example is polyethylene glycol. Polyethylene glycols are aqueous bases. Apart from this, the glycero gelatin bases are also the aqueous bases. Then the soap glycerine suppositories, these are also the aqueous bases. Then the third type is emulsifying bases. So for emulsifying bases, there are different examples. For example, Vitepsol is emulsifying base, Mesupol is emulsifying base. Then there is another example, Masa esterinum. This is also the emulsifying base. So these three main types of emulsifying bases are there. You must need to remember the examples. Then coming to next question. So the question is, which of the following is the oldest method for the preparation of suppositories? So there are different methods for the preparation of suppositories like hand molding, compression method, powder molding. So the hand molding is the oldest method for the preparation of suppositories. So here option A will be the correct answer. Next question is, rate of sedimentation is high in. So the rate of sedimentation is high in flocculated suspensions. So here option A is correct, and rate of sedimentation is low in deflocculated suspension. The rate of sedimentation, if it is low, then there will be chances of cake formation. Cake formation means a hard cake will be formed that will not be redispersed. What in case of flocculator suspension, there will be a rapid sedimentation. We can simply shake, and the cake can be redispersed. There is no formation of hard cake. So this is important. Then coming to next question. So the question is, cake formation is characteristic feature of. So cake formation that I have already discussed. This is seen in Deflocculated suspension, because the sedimentation is slowly formed and it will form a hard cake and every particle is present as an individual. Next question is, pharmaceutical suspensions are generally, so the pharmaceutical suspensions are generally the flocculated ones, so that there is no cake formation. So here option A is correct. Next question is, for ideal suspension, the sedimentation volume should be. So for ideal suspension, the sedimentation volume should be equal to 1. So here option B is correct. Next question is, Ostwald ripening can destabilize. So Ostwald ripening is a process which can destabilize the suspensions. So here option B is correct. Next question is, Brownian movement of particle sedimentation. So what is the effect of Brownian movement on particle sedimentation? So basically Brownian movement will prevent the particle sedimentation. So here option C is correct. Next question is, structured vehicle is included in the formulation of suspension in order to. So what is the role of structured vehicle in the formulation of suspension? So basically the main role is to prevent the sedimentation. So here option A is correct. Next question is, flocculated suspension exhibits dash flow type. So the flocculated suspension, they exhibit the plastic flow type. So here option C is correct. And the deflocculated suspensions exhibit dilatant flow type. Next question is, which is incorrect statement for flocculated suspension? We need to identify the incorrect statement for flocculated suspensions. So for flocculated suspension, the sediment is formed slowly, means the rate of sedimentation is high. So here the rate of sedimentation is basically high. So this statement will be incorrect, because incorrect statement is asked. So the particles form loose aggregate structure. This is true. Sediment is loosely packed, so it is easy to redisperse. This is the statement number 4. What the rate of sedimentation, as we have seen in the previous question, the rate of sedimentation is high. So it is not the case. It is the case in the deflocculated suspension. Next question is, for the preparation of cod liver oil emulsion, the ratio of oil is to water is to gum required is. So for the preparation of cod liver oil emulsion, the ratio of these oil is to water is to gum. This ratio will be 4 is to 2 is to 1. So here option A will be the correct answer. So this is for the cod liver oil. If there will be another examples, like I will be tell you the general types of oil. If it is a fixed oil, if it is fixed oil, for example, cod liver oil or castor oil or almond oil, or you can say arachis oil. So for all these kind of oils, the ratio is 4 is to 2 is to 1. If the oil is mineral oil, if the oil is mineral oil, then for example liquid paraffin or linseed oil, then this ratio will be 3 is to 2 is to 1. If the volatile oil is there, then in that case the ratio will be 2 is to 2 is to 1, or you can say 4 is to 4 is to 2, which is both the terms are same only. So for example, volatile oils, that will be turpentine oil, that can be peppermint oil, or that can be cinnamon oil. So these type of oils. If the type of oil is oleoresin, for example male fern extract, then this ratio will be 1 is to 2 is to 1. So these ratios you have to remember. Now we can move to the next question. So the question is, creams are, so creams, the nature of creams are basically the emulsion types. So here option A is correct. Basically main two types of creams are there: water in oil creams and oil in water creams. Then next question is, water in oil emulsifier have HLB scale value range. So the range of HLB scale for water in oil emulsifier is around 3 to 6. So option A is correct. If I'll talk about the range 1 to 3, then it will be anti-foaming agent. Anti-foaming agents. So its range will be from 0 to 18 or 20. So from 0 it will be more lipophilic type, and as the value will be increased it will started become hydrophilic. So hydrophilic term you can uh, you will be able to easily remember the category of surfactants based on the HLB range. As it is increasing, then the nature of the surfactant will start changing from lipophilic to hydrophilic. For example, here from 1 to 3 it is anti-foaming, means it will be oily in nature, so it will not form foams, so it will be anti-foaming. 3 to 6 it will be water in oil emulsifying agent, that means oil is in more quantity. Then from 7 to 9 it will be betting agent. It will be betting agent means now it will start changing from oily to hydrophilic, so it will be betting agent. Then there will be value 8 to 16. 8 to 16 is oil in water emulsifying agent. Now you can say see like there is a shift from oily nature to watery nature, aqueous nature. So there is a change. Now the next value is 13 to 16. For 13 to 16 or 13 to 15, the value will be for detergent. Detergents means it will start making the foam. Okay, so it will be detergent. If slightly higher value like 15 to 18, then it will be becoming solubilizing agent. It will become solubilizing agent. So you can start you can see like there is a shift from oily nature to the hydrophilic nature. Now it will start solubilizing. So these are the main important values for HLB scale. All values you need to remember. Moving to next question. So the question is, coalescence of the dispersed globules and separation of the dispersed as a separate layer in an emulsion is called. So it is basically an instability in emulsion in which the coalescence of dispersed globules and separation of dispersed phase will be there as a separate layer in emulsion, and this one is known as cracking. So here option A will be the correct answer. Next question is, which of the following is not a to the test method to test the type of emulsion? So basically for the testing or the identification of emulsion there are different tests that are used. Microscopic method test is there, conductance method, dye method, but coagulation method is not one of the method to for the identification of emulsions. So here option C is correct. So we can see like what different types of tests are there. So there is one dye solubility test. Dye solubility test basically in order to identify the either it is water soluble or it is means it is water in oil or oil in water type emulsion. So what happens in dye test is basically if we are using a water soluble dye, if it is a water soluble dye, then water soluble dye will dissolve in the aqueous phase. Okay, so this oil and water will be the aqueous phase mostly. So this dye will dissolve here and it will not dissolve here. So like that way we can easily identify like which one is a oil in water or water in oil type emulsion. We can check like what are the examples of water soluble dyes. For example, the amaranth dye. So amaranth dye is a water soluble dye, and scarlet dye, it is a oil soluble dye. So these two examples you can remember. The next method is dilution test. Next method is dilution test. So it is quite simple test, like oil in water and water in oil. If I'll add water in oil in water type emulsion, then there will be no separation. Okay, because already water in high quantity, so there will be no change in the order of this phases. What if I'll add oil here? So once the oil quantity will be higher, then it will be changing. So this oil in water will be diluted with water, and water in oil will be diluted with the oil. Then next test is conductivity test. Conductivity test. So in conductivity test, what happens basically? We have a emulsion. If it is oil in water, means water is in dispersed phase. So the it will conduct the electricity. Means we can place a bulb and proper wiring, and if the bulb glows, then it will be a oil in water emulsion. If the bulb does not glow, because water is in continuous phase. Okay, water is in continuous phase, not in dispersed phase. It is in continuous phase, so that's why it will conduct electricity. But if it is water in oil, then in continuous phase oil will be there, then that will not conduct electricity. So these are the main tests. Apart from this, there will be a fluorescence test. Fluorescence test. So in fluorescence test, what happens? The oils will give fluorescence under UV light, while water does not give. So if it is a oil in water emulsion, it will not give fluorescence, while if it is water in oil type emulsion, it will show fluorescence. Then there is another test, that is the cobalt chloride test. What happens in cobalt chloride test? So cobalt in this it is basically a water soluble, so it changes color when encountered by what oil in water. Okay, so basically in this cobalt chloride is used. Cobalt chloride is used for the identification of test. It is basically soluble in water. Okay, so it changes color when it goes in the oil in water. Okay, when we'll add the cobalt chloride in oil and water emulsion, it will change its color. So that is the main cobalt chloride test. So these are the different tests for the identification of emulsions. You can remember like how we can identify in each of the tests, and there can be a condition given in the question, like this is the condition, like uh, we are having a electrical conductivity test and the valve is not glowing. So from this observation, what is the type of emulsion? So in that way you can have a question based on the identification test. Next we can move to the another question, that is particle size of nano suspension is. So the particle size of nano suspension is 10 nanometer. So here option B will be the correct answer. So there are mainly three main types of suspension based on the size of solid particles. One is colloidal suspension, another one is coarse suspension, and the third one is nano suspension. In colloidal suspension, the size will be lesser than 1 micrometer. If it is coarse suspension, then the size of particle is greater than 1 micrometer. So these are the main types of suspensions based on the size of solid particles. Now coming to the next question. So the question is, which of the following test is used for determination of wetting agent? So for the determination of wetting agent, the test used is Draves test. So here option D is correct. So this test basically determines the bettability. It determines the bettability by calculating the time taken for wet skin. Okay, what is the time required, or what is the time taken for the wet skin of what? Wet skin of cotton yarn to sink in wetting solution. Okay, so this is a basically a test which is used for the determination of wetting agent. Next question is, dash are the liquid or semi-liquid preparations meant for application to unbroken skin by friction or rubbing of skin. So basically in this particular syllabus, lotions are asked. Okay, but I have added a question on the liniments. So this is liniments which is applied with rubbing or with friction to an unbroken skin, and it is a semi liquid or liquid preparation. So these are the liniments. The opposite is the lotion, like if it is on the broken skin or with without friction, or without friction, you need to remember without friction is lotion and with friction is liniment. You can simply remember with and without. In without there is O, and in lotion there is O. In with there is I, or you can say like without O is liniment, because there is no O in the liniment. So in that way you can remember the difference between liniment and lotion, which is given, which is applied with friction and which is applied without friction. So here the answer will be option number B. Now we can move to the next question, or we can also have an examples for these. So for liniment or for lotions, we have different lotions. For example, calamine lotions, we have hydrocortisone lotion, and also we you must have seen several body lotions that can be available in your home, like for the Vaseline lotion. So these kind of lotions will be there. For liniments, there are different, like there is camphor liniments, there are turpentine liniments. So these are the examples of liniments. Then we can move to the next question. So the question is, dash are semi-solid preparation meant for external application to the skin or mucous membrane. So ointments, paste and creams, these all are the semi-solid preparations. They are applied externally and they are applied on the skin or mucous membrane. So here the option D, all of the above will be the correct answer. Then coming to the next question. So the question is, which of the following ointment base is absorption type? Now we need to find the type of ointment base which is absorption type. So here wool fat is the absorption type of ointment base. So previously we have seen the suppository base. Now we can discuss few of the ointment bases. So ointment bases are similar kind of classification is there, similar type of examples are there, so that we can easily remember. So for first one is oleogenous bases, oleogenous and hydrocarbon bases, in which different oils will be there. For example, olive oil, there is almond oil, there is sesame oil, and several other oils like cottonseed oil and other you can easily find out. These all oils are the natural oleaginous bases. There is one silicones, these are the synthetic oleaginous bases. Then we can come to the second type, which is absorption type bases. So absorption bases types can be anhydrous, these can be anhydrous or hydrous. In anhydrous, there are different examples like the wool fat, which is anhydrous lanolin. There can be hydrophilic petrolatum is absorption base. Then in hydrous absorption bases, lanolin. There is lanolin, which is hydrous wool fat, that is 70% wool fat and 30% purified water. There can be a rose water ointment. There is cold cream, wool alcohol ointment. These are the hydrous absorption bases. Then the third ointment base is emulsion base. Third is emulsion base. In this, there are different examples like water in oil bases or oil in water bases. So in water in oil, there can be cold creams, there can be lanolin or rose water ointment. For oil in water, there can be emulsifying bases, there can be cetrimide emulsifying bases. So these type comes under emulsion bases. Then the fourth type of ointment base is water soluble. It is water soluble base, which is the also known as greaseless ointment base. So here the example is polyethylene glycol, which is also known as carbobex. So this can also be asked like which type of ointment base is carbobex. So this is water soluble base. Now coming to the next question. So which of the following is water in oil creams? So basically there are two types of creams, oil in water, water in oil and oil in water. So in water in oil, the oil will be the continuous phase, and water in oil are mostly used in external use only. These are for external use purpose only. And here you can find the different examples like the moisturizing creams, there can be moisturizing creams, there can be cleansing creams, there can be cold creams, there so these all are the types of water and oil emulsion creams. Next is oil and water emulsion creams. So these can be used internally as well as externally, and the examples will include milk, the shaving creams, the vanishing creams. These are the examples of oil and water emulsions. So these examples you can remember. So like this way the question has been previously asked. Next question is which of the following route has 100% bioavailability? So the 100% bioavailability can be seen with the intravenous route of drug administration. So here option A will be the correct answer. So for the doses, there can be other routes of parenteral preparations, for example, the intramuscular route. So here the absorption, the bioavailability will be lesser, but quite high bioavailability, as these are the parental routes of administration. Then we can also check the doses, like what kind of doses will be given in different routes of administration. So few routes are very important. For example, intradermal. So intradermal, the dose requirement is around 0.1 to 0.2 ml. If I'll say the intramuscular route, for intramuscular route it is 2 to 4 ml. For so these are the basic things. Okay, these two are the most important. Then we can move to the next question. So the question is which of the following are the evaluation test of ophthalmic preparations? So the evaluation test for ophthalmic preparations include sterility testing, clarity test, leakers test. So these are the different evaluation tests for ophthalmic preparations. So here option D, all of the above is correct. Pyrogen testing is not done in ophthalmic preparation. This is done in the parenteral evaluation test. So here we have discussed around 71 important questions from all the different topics that are mentioned in the syllabus. So rest the additional information you always must have to remember. Apart from this, we can discuss few important points like that I have left in the questions. So the evaluation test for suppositories. What are the different evaluation tests for suppositories? Like question can be asked like which of the following is not a evaluation test of suppositories, or which of the following is a type of evaluation test for suppositories. So here you can find the appearance, uniformity of weight, melting range test, liquefaction or softening time test of for rectal suppositories. So this you can find like for which type of suppositories liquefaction or softening time test is there. Then there is breaking test, hardness test, dissolution testing. These are the different evaluation tests for suppositories. Also in another point is therefore physical instability in emulsions. So there is a type of physical instability, that is creaming, which is due to the density differences and due to the concentration of globules at the top or bottom of the emulsion. So the basic difference is there. It is due to the density differences. And how we can identify this type of emulsivity, like instability. So in this two type of emulsion, in water and oil emulsion, this question can be asked, like downward creaming is observed in which type of emulsions. So in water, in oil, okay, so water in oil, oil is in higher quantity, so it will be the downward creaming. And in oil and water, it will be upward creaming. So like if the oil is in lesser quantity, then it will be float on the water. Okay, so then the creaming will be the upward on the towards the oily surface. In water and oil, the oil is in continuous phase, more quantities of oil that will be distributed all over the container, so it will move downward. So these 2 points you can remember. Next, we can move to our next and last topic of this particular unit, that is the study of immunity, immunological products like sera, vaccines, toxins, and their preparations. So in this, I have added a limited questions, so which are very important. So let's start with the first question. So the question is, anti-serum is also known as, so anti-serums are also known as antitoxins. So quite direct question. So option C is correct. Next question is, both antisera and antitoxins are administered in human by dash route. So antisera and antitoxins, these are administered by which route in humans? So these are administered by the parental routes. So option C is correct. Next question is, dash is the site where maximum immune response is achieved. So at which site the maximum immune response is achieved? So this site is spleen. In the spleen part, the maximum immune response is achieved. So here option B is correct. Next question is, who invented successful immunization against smallpox? Okay, so who, the smallpox vaccine was invented by Edward Jenner. So it was invented in 1798. You can simply cross check the year. So it will be mostly 1798. So Edward Jenner was the first scientist who invented the successful immunization against smallpox. So option B is correct. Next question is, in DTP vaccine, P corresponds to. So in DTP vaccine, it is a triple vaccine for the immunization against triple agents. So in this, the D stands for diphtheria, D stands for diphtheria, T stands for tetanus, T stands for tetanus, and P stands for pertussis. P stands for pertussis, and pertussis is also known as whooping cough. So here option B, whooping cough, will be the correct answer. Next question is, vaccines impart. So vaccines will provide which type of immunity? So vaccines basically provides active immunity. So here option A is correct. So vaccines are basically providing the active immunity. They basically act as an antigen which induce production of specific antibodies by the recipient himself. Okay, so the our body will automatically produce some specific antibodies to protect our body against that particular antigen. Then there is another condition, like there can be antiseras or immunoglobulins. So these two types, antisera and immunoglobulins, these imparts or these provides passive immunities. So what they have? So they have the ready-made antibodies, and these ready-made antibodies are simply transferred. Then we can move to next question. So the question is, dash vaccines designed to immunize against two or more strains of the same microorganism or against two or more microorganisms. So what type of vaccines are designed in order to provide the immunization, or in order to provide the immunity against two or more, or we can say against multiple strains of the same organism, or two or more different organisms. So these type of vaccines are known as multivalent vaccines, or you can say polyvalent vaccines. Another name is polyvalent vaccines. If the vaccine is designed to provide immunity against only single agent or single microorganism, then that type of vaccine is known as monovalent vaccines, or you can say univalent vaccines. So these two terms also you need to remember. Next, we can move to the next question. BCG vaccine is a type of, so BCG vaccine, it is a vaccine for the tuberculosis, and and BCG stands for Bacillus calmette guerin. So it is a type of live attenuated bacterial vaccine. It provides immunity against the bacteria, which is a type of live attenuated bacterial vaccine. And the other type of vaccines, like there is a broad category like killed bacterial vaccines, live attenuated bacterial vaccines, killed viral vaccines, live attenuated viral vaccines. So I have provided a chart of these different types of vaccines. You can simply check that in the PDF, and I will also be discussing in this particular video regarding that chart. So from that you will be easy to remember the different types of vaccines, like which one is a bacterial, which one is viral, and which one is killed or live attenuated. Now coming to the next question. So the question is, which of the following strain of cholera is used in vaccine? So for the production of vaccines of against cholera, so which strain is used? So the Inava and Ogawa strains are used of cholera in vaccination. So option B is correct. Next question is, which polio vaccine is used orally? So for polio vaccines, the polio vaccines can be given orally as well as through the parental route. So orally, the vaccine which is given is Savine. So it is given orally, and the Salk, it is given by the parenteral route. So these are the two main types of polio vaccines which are given. Next, moving to the another question, that is temperature used for sterilization of vaccines is. So for the sterilization of vaccine, the temperature requirement is around 55 to 60 degree Celsius. Next question is, what is the storage temperature for smallpox vaccine? For the smallpox vaccine, the storage condition is 2 to 8 degrees Celsius. So most of the vaccines are stored at this particular temperature, 2 to 8 degrees Celsius. Only few, like the COVID vaccines, so few vaccines are stored even at a very low temperature. That is the main disadvantage at that time for their transportation and other things. So if you can say, like for the smallpox vaccine, it is stored at 2 to 8 degrees Celsius, and it is punctured into the skin. It is given by puncturing into the skin. Other vaccines like the cholera vaccine, the BCG vaccine, the yellow fever vaccines, or rabies vaccine, these all are stored at a temperature 2 to 8 degrees Celsius. And if I'll talk about the route of administration of these vaccines, so the cholera vaccine, it is given by subcutaneous route. The BCG vaccine, it is given by intracutaneous or intradermal route. Then there will be yellow fever vaccine. Yellow fever vaccine, so this can be given by subcutaneous route. And the rabies vaccine is also there. So rabies vaccine is given by subcutaneous route or intramuscular route. So these are the different vaccines and their storage conditions and storage route of administration. Next question is, which of the following is used as live attenuated vaccine? So we need to find out the which one is the live attenuated vaccine. So here they haven't mentioned like whether it is a bacterial vaccine or the viral vaccine. So here BCG and Sabine vaccine, these both are the live attenuated vaccines. So here option C is correct. Next question is Sabine is dash type of vaccine. So Sabine is basically a live type of vaccine. So option A is correct. So now I have provided you one table in this table is from the KD Tripathi pharmacology book. So you can simply find out like which one is a killed vaccine or live attenuated vaccine. I have added this figure in the PDF also. So you can simply download the PDF and you can simply check this type of things. So there are two columns, like one is killed or inactivated vaccines, another one is live attenuated vaccines. Then they have categorized under bacterial and viral vaccines. So in bacterial vaccines, bacterial live attenuated, there are BCG vaccine. Mostly the question is asked for on BCG vaccines. And the other one is typhoid TY21A vaccine. So here you can see like typhoid can be the killed vaccine as well as live attenuated. So based on the strains or the type of vaccine, so it is categorized as this. Then cholera, whooping cough, meningococcal, Haemophilus influenza type B, plague. These are the killed bacterial vaccines. Now for the viral vaccines, there are polio oral live Savine vaccine. You can see the Savine is viral live attenuated and Salk is for polio only. It is a viral killed vaccine. So this can create a confusion. So you can remember these things. The Savine is live and Salk is killed vaccine. Then another vaccines are mumps, measles, rubella, varicella. These are the live attenuated viral vaccines, and the other one is rabies, influenza, hepatitis B, hepatitis A. These are the killed viral vaccines. Then another one are toxoids. So tetanus and diphtheria, these are the toxoid vaccines. Then there are combined vaccines like the double antigen DT and DA vaccines, and the DPT vaccines, measles, mumps, and rubella vaccine. So here MMR, you can find out like what is MMR, what is the full form, or what kind of against which diseases the immunity is provided with the MMR vaccine. So it is measles, mumps, and rubella. Then there are pentavalent. Pentavalent means five protection against five vaccines. So it is DPT. DPT is diphtheria, pertussis, tetanus, hepatitis B, and H influenza type B. So these are the pentavalent vaccines. So in that combined vaccine, the question can be asked. So this table is very important from this particular topic. So why this topic, we are completing this particular unit number 1. Most of the important topics are already covered, and if you want to do any extra information, so you can simply check out on the Google, like if whatever topic if you want to learn. So you can also mention in the comments, we can include that topic in other subjects, the summary points we can make from those. And so that's all for this particular video, and do share with your friends, like whosoever is preparing for this particular exam, so that they can get benefit from this particular series. And next we are going to start the human anatomy and physiology subject. And like I have seen one comment like to start the pharmacognosy subject first. What I should say, like we can go in the same series, like the unit wise, unit 1, 2, 3, and then up to 10. So like that way it will be easy to compile all the things, and to proceed the series in a better way. So that's all for this video. We can meet in the next video. Till then, thank you and bye.